Good morning, everyone. This is Miss Xiao here. Today, I would like to share with you a topic from the Primary 5 Mathematics syllabus called Properties of Triangles and Quadrilaterals. Now, triangles is something that you are familiar with. You have learned it since your preschool days all the way to now, when you learn area of triangle at first term of primary 5. And later part of the year, which is now, that's where you come across something called a four-sided figure. Now, four-sided figure can also be referred to as a quadrilateral. Quadrilateral, the root word comes from quad, quarter, meaning four parts. All right, so let's take a look at angle properties first before we come into triangles and quadrilateral properties. Now, we'll do a recap of the properties of angles that you have learned in primary 3, 4, and some of which in primary 5. Now, the first property that we're going to recap is actually called angles on a straight line. So, if you were to look at the three lines on the right-hand side of the screen, okay, they are straight lines. So, I'm going to label them. This line is labeled as AB. We have another line, CD. Now, these two lines, I'm going to make it parallel to each other. Okay, and cutting the two lines across is another line that is referred to as EF. Now, this one line that cuts the two parallel lines across is actually called a transversal. You will not be covering this term in primary school, but however, you will be familiar with it when you reach secondary 1. Now, angles on a straight line basically refers to all the angles that are covered with regards to one straight line. So if we were to refer to line AB, okay, and if we were to consider this angle here, let's say this angle here is A, and the other angle is small letter b, then we could say that angle A plus angle B, since they both lie on a straight line, they add up to 180 degrees. Okay, this one you should be familiar with already. Okay, now next we want to move on to the second property, which is called angles at a point. So let's say if we were to have a point, okay, I'm going to label the point, I'm going to draw out a green point, and it will be here. Okay, this is the point. And what I'm going to do next is I'm going to label the rest of the angles that are around the point. So this angle over here at the bottom, I'll label as C, and I have another one at D. Now you realize that there are 4 angles around that particular point in green, right? And all 4 angles actually would add up to be 180 degrees times 2, because you realize that at the top, above line AB, this makes 180 degrees, and below line AB, this makes another 180 degrees. So if you were to add up both angles of 180 degrees, you will have 360 degrees. So angle A plus angle B plus angle C plus angle D will give you 360 degrees. So this is angles at a point. Now, we're going to move on to vertically opposite angles. Vertically opposite angles focuses on angles that are opposite to each other, okay, when the two lines cross each other. So if you were to look at this angle over here, A, and angle C, now you realize that they are opposite of each other. Yeah? And on the other hand, if we were to look at angle B, it is opposite to angle D. Now, what can we say about these angles? Now, let's say if we were to assign an angle, of angle A of it to have a degree of say 130 degrees. Okay, and bearing in mind that line AB is a straight line, we could find out the angle for B. B using angles on a straight line would be 180 degrees minus 130 degrees, and that will give us 50 degrees. Subsequently, if we were to consider line EF as a straight line, and we know that angle B is 50, we could possibly find angle C by again using angles on a straight line by taking 180 degrees minus 50 degrees, and that gives us 130 degrees. Lastly, we could find the angle D by looking at angles on a straight line again. Below line AB, okay, you will see that it's made out of 130 degrees and angle D. So angle D is actually 180 degrees minus 130 degrees, which gives us 50 degrees. Now, bearing in mind all these angles that we have found, what we can take note of is that angle A is actually equals to angle C. Okay. Angle B is equals to angle D. So this is what vertically opposite angles tells us. The angles that are opposite to each other, okay, made up of two straight lines, is actually the same. So I'll put this down. Angle A equals to angle C, and angle B equals to angle D. Now, next, we're going to move on to interior angles. Interior angles refers to angles that are inside something. Inside what? Now, it's actually angles that are in between a pair of parallel lines. So let's say if I were to assign the angle at the bottom here on line CD as angle E, okay, and if I were to pay special attention to this portion over here, angle C and angle E both lie inside a pair of parallel lines. And the pair of parallel lines will be AB and CD. Now, the two angles there, C and E, actually add up to 180 degrees. Now, other than that, if we were to assign another angle here to be F, angle D and angle F also add up to be 180 degrees. So that's interior angles. Now, we're going to move on to the next one, which is called alternate angles. Alternate angles is very interesting. Okay, let's take a look. Alternate angles, we have to look out for zigzags. What kind of zigzags? Something that looks like the letter Z, or something that looks like the letter N. Okay, and one thing you have to bear in mind is that the two lines, okay, the one on top and the one at the bottom, in this case, are parallel to each other. Now, when you're able to locate something like a Z, okay, what you need to know about alternate angles is that angle D, okay, the angle that is enclosed within the top part of the letter Z, and the letter E is actually equals to each other. So if angle D equals to angle E. Now, there is actually another pair of alternate angles that we can observe from here. let me use the color purple. So I'm going to, this is an inverse Z. Yeah, okay, you notice that again, there is a pair of parallel lines, AB and CD. Now, we have angle C and angle F that correspond in this pair of alternate angles. So therefore, angle C is also equals to angle F. Next up, we have corresponding angles. Now for corresponding angles, you have to look out for angles, again, that are located like that. Okay, resemble something like the letter F. And of course, the two lines that are stretched across are parallel to each other. Now, you realize that there are two angles over here and here. Okay, let me assign the one at the bottom as angle G. Now, they are actually the same. Okay, so angle C is actually equals to angle G. On the other hand, if you were to look at another pair, the same pair of parallel lines, line AB and line CD, okay, you can also spot another pair of corresponding angles. Here, you have angle D being equals to angle H. What a handful of properties. Yeah. So these are the properties that make up angles in general. Next, we're going to move on to triangles, and let's explore the properties of triangles. Now, triangles are shapes with three sides, and with three sides come three angles. And all the angles will add up to be 180 degrees. I trust that in primary 4, you will have learned how to measure angles using a protractor. Yeah, if you were to draw any triangle, all right, and use a protractor to measure all three angles, somehow or other, they will all add up to 180 degrees. Yeah, so if you're not too sure about it, take a piece of paper, draw on it, use the protractor, measure all angles, add them up. It will be 180 degrees. That's a fact of triangles. Now, let's take a look at the types of triangles. We have what you call a right-angled triangle. And for the right-angled triangle, one angle has to be 90 degrees. The other two angles over here will both add up to be another set of 90 degrees. So let's say if angle BAC is perhaps 50 degrees, then we will say that angle ACB will be 40 degrees, such that when you add up all three angles, it will be 180 degrees. Now, we move on to the second type of triangle, which is called the isosceles triangle. Isosceles triangle tells you that there are two sides of the triangles that are of equal lengths. So it is indicated by a stroke here. Okay, the stroke tells you that line AB has the same length as line AC, and its corresponding angles are the same. Now, how do we determine what the corresponding angles are? We determine by seeing where this line AB actually points to. It actually points to angle C. All right, and line AC actually points to angle B. So we could say that angle ABC is equals to angle ACB. Okay, other than observing that AB is equals to AC. So that's the property of an isosceles triangle. So let's say if I were to give an angle of perhaps 70 degrees to angle ABC, Then we will also say that angle ACB is 70 degrees because it's isosceles. And therefore, we could find what angle BAC is. Angle BAC would be 180 degrees minus 70 degrees minus another 70 degrees, and that will give you 70 and 70 makes 140, right? 180, take away 140, you get 40 degrees. So this is an example. Next up, let's take a look at equilateral triangles. Equilateral triangles comes from the word equal, which means all sides have the same length. And because all sides have the same length, all angles are equal. Now, if you take note and you remember, all angles in a triangle add up to 180 degrees, right? So if all angles are equal, therefore each angle in an equilateral triangle will be 180 divided by 3, which gives each angle 60 degrees angle. Okay, and furthermore, if you want to mark that all sides have the same length, you could do something like that. So that's an equilateral triangle. Lastly, we explore scalene triangle, whereby all sides have different lengths, and because all sides have different lengths, all angles are different. The longest length corresponds to the largest angle, whereas the shortest length corresponds to the smallest angle. Alright, so if you were to look at the last triangle, you realize that this is the longest length. It will correspond to the largest angle. Yeah? The smallest length will correspond to the smallest angle. Yeah? And the length that is intermediate will correspond to an intermediate angle. So this summarizes the properties of different types of triangles. Next, we're going to move on to quadrilaterals. Now, what are quadrilaterals? Just now I did mention, it refers to four-sided figures. Okay, so these are the four-sided figures that you will be learning in primary 5, some of which, the rectangle and the square, you might already be familiar. And if I'm not wrong, you will have covered this in primary 4. So let's take a look at the properties of a rectangle. So properties of a rectangle, take note that there are two pairs of parallel sides. Yes, so this is one pair, and this would be a second pair. Now, what else? All angles are right angles. So each angle at the side is 90 degrees. Opposite sides are equal. Yes, definitely all opposite sides are equal because that's the property of a rectangle. And that's about it for rectangle. Of course, we can find the total, the sum of all angles in a rectangle. If one angle is 90 degrees and all four angles are equal, that means the total angle is 360 degrees. And this actually applies across all quadrilaterals, regardless of how it's been drawn. Now next, we'll take a look at figure B. Figure B is a trapezium, and a trapezium consists of one pair of parallel sides. Okay. And because there is one pair of parallel sides, we could say that, well, we observe that these two angles here are interior angles. So angle A, if you add to angle B, that gives you 180 degrees. Angle C, if you were to add to angle D, that will also give you 180 degrees. Now, next, parallelogram, that's figure C. Figure C says that, figure C shows that there are two pairs of parallel sides. So this is one pair of parallel side, and a second pair of parallel sides. Basically, a parallelogram is a rectangle, but it is slanted at an angle on two sides. Okay, and opposite sides are also equal. Next up, rhombus. Rhombus has two pairs of parallel lines. You realize that some of the properties overlap, yeah? Opposite sides are equal. And not just that, all sides are equal. So a rhombus is like a square whereby its two sides are slanted at an angle. Lastly, let's take a look at a square. A square has two pairs of parallel lines. We have all angles being right angles. Opposite sides are equal. And all sides are equal. So that's the property of a square. Now, in the next few slides, we are going to take a look at individual shapes, and we are going to look at the minute details of some properties that we can find in these shapes. So let's see, rectangle. We know that all sides are 90 degrees. Yes, so we'll put that down first. We know that there are two pairs of parallel lines. So if there are two pairs of parallel lines, we can say that the sides that are opposite of each other are actually of the same length. Okay, so if I were to label A, B, C, and D, we can say that AB is equals to DC. Yeah, and AD is equals to BC. Now, what other properties can we observe from a rectangle? Perhaps one thing that we can observe from a rectangle is when we start to draw a diagonal. Okay. Now, when we draw a diagonal across from B to D, what we notice is that we see that it's made up of two right-angled triangles. Yeah? Okay, and what else? Let's say if we were to draw another diagonal. You would notice that actually, okay, this point in the middle is right smack in the middle of the rectangle, which makes, let's say if I were to label the point below as E in the middle, triangle ABE to be an isosceles triangle, and it's exactly the same as triangles DEC. On the other hand, we notice that at triangle AED is exactly the same as triangle CEB. So these are things to take note of. Now, what else can we observe from here? Many more. Now, if you look at this angle here, angle A, B, and D. Let's say if I were to look at another angle that will correspond to this, that would make up an alternate angle. Are we able to do so? Now, alternate angle, we need to look for something that looks like a letter Z. Yes. Okay. Now, this actually corresponds to this angle over here. B, D, C. They are equal. Now, conversely, if you were to take a look at another an inverted letter Z, okay, that looks something like that, down the diagonal. What you do notice is that this angle over here, BAC, is equals to the angle at the bottom, ACD, and it's due to alternate angles. Yeah. What else do we see? What we can also see is this angle, these four angles over here, form angles at a point. What else could we see? We could see that the two angles here, because it's isosceles, they are the same. So we could say for these two angles, they are exactly the same. With regards to the bigger triangles, top and bottom, we could also say that these two angles are the same. And these are the same. Okay, so there are many things to look out for. Yeah, lastly, not forgetting to point out vertically opposite angles. So these two angles are the same here, and these two angles are also the same due to vertically opposite angles. It's quite a handful, yeah, isn't it? All right, let's move on to the next. We have square, and square again, all four sides have 90-degree angle. We have two pairs of parallel lines. We have all sides being equal. What else can we say? Now, if you were to draw a diagonal and again, okay, you will see that, okay, since a diagonal is drawn, each triangle is actually isosceles. Now, given that it's isosceles and one of the angle is 90-degree, what we can say about these two angles being equal is that it is 45 degrees and 45 degrees. Same for the other two angles over at the other triangle. Okay. Now, if I were to draw another diagonal across, we could safely say that for the other angles as well. Okay, and because of that, what's in the middle point, let's give it as point E. That actually forms a right angle. All right. We'll move on to the next, parallelogram. We know that parallelogram has two pairs in fact, of parallel lines. The opposite sides are the same. What else can we say? Well, if you were to look at this particular angle here, let's label it angle A, the rest B, C, and D accordingly. Now, the opposite angles are the same. So let's say if angle A is 70 degrees, now based on interior angle, we could find angle B as 110 degrees. That's interior angles because both angles add up to 180 degrees. So from there, we could find angle C using using interior angles again. 180, take away 110, that makes 70. And angle D will be 110 degrees, again based on interior angles. So what we can observe from here is that angles in a parallelogram, okay, that are opposite to each other, are actually the same. Opposite angles in a parallelogram are the same. Okay, so just take note of that. This is a very useful hint. Okay, now let's take a look at the case where you draw a diagonal. Okay, from C, if I were to draw a diagonal to A, and from B, if I were to draw a diagonal to D, what are the observations of angles or special angles that I can make? You notice that there is actually a letter Z somewhere here. Yes. Now this means that there is some there's a presence of alternate angles. So this angle over here is the same as this angle over here. Yeah? Okay, alternatively, there is an inverted Z where you can see it somewhere here. It's kind of messy because there are so many properties, yeah? This angle over here corresponds to the angle at the bottom due to alternate angles. What else can we observe? There are more alternate angles if you notice. You look at Z over here. Okay, and we have this angle being the same as the one over here. And one more pair of alternate angles. This angle over here being the same as the other angle. Okay, so with this, we end off parallelogram. Rhombus. I guess after looking at so many shapes, you kind of get a hang of certain properties. Rhombus, we have two pairs of parallel lines. Okay, when we have parallel lines, we always need to look out for things like interior angles. We need to look out for things like alternate angles. Yeah. What else? For a rhombus, we have all sides being the same length. Okay, and if we were to cut it across, what you notice is that you form two identical isosceles triangles. Yeah. Okay, and due to that, you notice that these two angles are the same. And on the right, triangle on the right, we have another two angles that are the same. And the four angles, A, B, C, D, are actually equal to each other. Now, if we were to, maybe I will just put that down. Angle A equals to angle B equals to angle C equals to angle D. If I were to draw another diagonal across the rhombus, I would form yet another two pairs of isosceles triangles. Let me just draw it out for you. This is isosceles triangle. One. Okay. And we have another isosceles triangle over here. Okay. Now, because of this, the angles E, F, G, H are the same. Okay, and next up, if you were to look at this portion here in the middle, all angles in the middle are 90 degrees each. So we can say that a rhombus, when it is cut, when there are two diagonals that are drawn across it, it forms four identical right angle triangles. Yeah, so that's quite interesting. And I hope that you are able to follow the lesson so far. All right, lastly, we'll look at trapezium. Trapezium has one pair of parallel lines, and that's about it. And we could observe, as I said earlier on, these two form a pair of interior angles. That means they add up to be 180 degrees. And so it's the same for the other two angles, which add up to be 180 degrees. But just take note that if you were to add angle A to angle D, this does not make 180 degrees because the two lines, yeah, that angle A and D are within is actually not parallel. So the condition for interior angles is that the two angles need to be within two lines that are parallel to each other. So just take note of that. And for trapezium, it is typical for questions to draw a diagonal as well. Okay, and from here, what you could see is that this angle over here corresponds to the angle at the bottom through alternate angles. These two angles are the same. And if I were to draw another diagonal, okay, you see another Z here. So this other angle over here corresponds to the angle at the bottom. Yeah. So that's all for the properties of triangles and quadrilaterals. I hope that you will have got a better understanding towards this topic and able to handle questions from it. Take care and goodbye.